Welcome, everybody. Thank you for joining us on our series, Saving Money in Oil and Gas Operations. This episode is specific on asset integrity and repairs. We created this series to allow subject matter experts to come on and just share their knowledge with the industry, oil and gas industry, so that way we can increase our learning curve and make sure that we get through this thing. So staying in the know, a little bit of housekeeping before we get started. If you have any questions, if you're new to Zoom, there is a question and answer box that you could be typing in questions. We'll be trying to answer those questions as we go through the presentation, but we will have a Q&A section at the end. So if you have any questions for Jesse that you want to go through, we'll be answering them at the end as well. Now, towards the end, now a lot of y'all might be working from home, so kids might walk in, power goes out, you might have to take a phone call. Don't worry about everything. So what we'll do is we'll download this video and then re-upload it to our YouTube channel and our blog, so that way you can be looking at it afterwards. Now for meeting the speakers, my name is Cameron Croft. I am Chief Executive Officer of Croft Production Systems, a natural gas processing company. We focus on domestic and we sell equipment internationally, natural gas processing equipment. I got my engineering degree from the University of Houston along with my master's, and I'm a black belt in Six Sigma, so I love data, I love continuous improvement. That's why I get to talk to people like Jesse, who can give me more information to, continuously improve. But the real reason for y'all to come on today is y'all are wanting to watch Jesse, hear what he has to say. So Jesse started his career with Maverick Engineering as a design engineer and working on facility designs, gas gathering facilities, infrastructure projects. He worked himself up to division manager. From that, he got his PMP and then actually started his consulting company working on civil projects and oil and gas infrastructure facility projects. And doing that over 8 to 10 years, consulting, he actually went ahead and created his own equipment and pressure vessel manufacturing company. So taking all this quality knowledge that he had, the experience from had, and now he's applying it into his own company called O-Synergy. So I've been working with Jesse for the last 10 years, and he's a great resource to talk to pick up the phone and say, this is the problem I'm having, and he's always there to assist. So appreciate Jesse actually coming on board with us today and sharing his knowledge. So he created his highlights, and I told him, Jesse, I need you to come on and talk about how you could save money in oil and gas operations. What would you tell a client? So he created his topic highlights of operating within equipment design parameters, asset integrity management, repairs, alterations, re-rates, and repurpose. So these are the big key things that he is focusing on today. Now, starting it off, Jesse, why did you want to be a part of this series?
Well, first of all, thank you for having me, and you've done a great job putting this sharing platform together. It's very beneficial, and we learned a lot. Like many, I've learned a lot from other people, from their knowledge, from their experience, and for that, I'll be forever grateful. I've cut my learning curve a lot, right? So I believe that if one item in this presentation helps somebody save time, save money, or especially save headaches, then I've done my part of passing it forward. And that's really the key thing why I'm doing this.
That's good. Well, kicking us off on the project. So this is one thing that I asked you is, everyone's trying to save money right now. They're moving equipment from one location to another location. They're doing a lot of things and just trying to save assets and save the money rather than having to manufacture new going into it. So, and you really focused on this. So kind of tell us about what you're talking about with, operating within the design parameters.
Well, this is one of the first steps. If you do a PSM of any sort, whether a HAZOP or even a what-if review, you'll capture or you'll evaluate each of these items. But these are some of the big items that I think are very important when you're selecting or especially relocating equipment. Making sure it's designed for the right pressure, making sure the material selection is the correct one, that it has the capacity, etc. So in the following slides, we'll go over, what happens when you exceed your maximum allowing working pressure, when you exceed your minimum design metal temperature or your maximum design metal temperature, when you exceed velocities, when you use equipment that was for standard service in solar environments and things like that.
Absolutely. And I like this next slide. You have a lot of good tips on here. So yeah, explain this to us.
So let's talk about overpressure. The potential impacts, of course, are anything from stress cracking to deformation to rupture, any acid loss, and of course, you could get into human injury or loss and environmental exposure, right? So some quick examples would be even as simple as hydro testing. We've heard of individual, for example, if you're using a digital pressure gauge, just selecting the wrong units. I mean, before you know it, say, hey, this thing ain't going up, and boom, you overpressure. And then people say, hey, nothing happened, it just bolts, but hey, you already overstressed the equipment, right? Another might be a failure, right? A PSV doesn't, operate and you overpressure it, or you have a fire and it just doesn't vent, it doesn't have full flow, so therefore you overpressure it. So that's one. Exceeding minimum design metal temperature or maximum design metal temperature, again, you have a lot of the losses, right? But you have potential brittle fracture, you have stress fracture, and of course you get into the leaks, the rupture, the acid loss, and human injury or loss and environmental exposure. Now, some of the things here are, let's say, I'm in South Texas, right? So it's pretty warm down here, but imagine moving equipment that was designed just for this area, moving it up to Canada or North US, right? So all of a sudden we focus on pressure most of the time. We really don't look at the temperature. So imagine something that was designed for 22 degrees and you take it to -50, right? So that's where you'll have these potential issues. Likewise, a lot of times we focus on pressure. Let's say all of a sudden you have gas coming in at 150 or 160 degrees. Well, flanges start derating after 130. So if you don't watch it, you're going to basically start operating at a pressure that is no longer 1440. It really needs to be derated as well. So that's where you would want to be careful along the temperature side.
Well, that
on the exceeding velocity, I'm sorry?
No, I'm sorry to interrupt. Actually going through this the other day, because we carry a lease fleet. So like you said, is we had some equipment in Texas and we were actually shipping it to Northern Ohio. And we started kind of looking at the plaques. And when you were talking about temperature the other day and getting to know you, we actually updated our asset management software now to actually put that in there. So that way it will kind of red flag us of like, here's a notification warning before you start doing something in a geographical area. So that really helped us out on our lease fleet.
Absolutely, that's great. So we move on to exceeding velocities or flow, right? And then again, potential impacts there. You have erosion, metal loss, plugging, leak, acid loss, etc. Some examples here would be, especially on a multi-phase system, would be if a lot of time we move equipment and we say, hey, we operated, 10 million on this unit, we'll move it to the next well, it does 10 million. However, if you had a lot more liquid on the second unit, you potentially are going to have erosional issues. Or if you have a lot of solids like sand, of course, sand plays a big factor. It'll start eroding, and before you know, you'll have a lot of metal loss and you'll have leaks. So that's just things to really look at as far as the velocity side. And then we move on to corrosive chemicals or gases. Of course, obviously, you're going to have corrosion, pitting, damaged seals on your instruments. Coking or solidification, if the chemical interacts or reacts with your product. And then you potentially have acid and human injury and so forth. Some example would be, moving equipment from a standard service where there's no H2S or sour gas and moving it to a sour gas area. Then you might be okay, but it's going to start eating your metal, especially if it wasn't NACE compliant to begin with, right? So, through time, you're going to have pits, stress cracking, and pinholes, and so forth. So, in summary, each of these, even when we're trying to use our existing equipment because we're trying to save money and not buying new, you really want to consider, what am I using this equipment for? And what are my risks in using it, and have I checked all my boxes off, right? So that will be one way to make sure you don't have any more operational costs than your initial by having some incident occur.
Well, and that kind of leads into the next one, asset integrity management, which we keep pressurizing or putting pressure on asset management, but actually adding the integrity side to it, that's another thing that we're adding right now. By talking with you, we're adding into our asset management software right now is actually the integrity of the equipment, doing routine inspection. So I really like what you're doing here. So if you can kind of go in depth of what you're talking about, equipment failures.
Well, this is a pretty broad topic, right? We're trying to just capture a couple of key points here. So when we talk about the asset management, you have some potential contributors that are going to really create some issues to your equipment. Again, you have H2S, CO2, chemicals going in there. You have norm from downhole. You have operating above design, and we talked about these, whether it's pressure, temperature, or velocities, or just plain simple lack of cleaning and preparation before you store it. And this is kind of tailored a little bit to cover the broad range, right? You have production equipment that's really in the operating constantly, and then you have equipment that might be testing, or simply that you're not going to use it and you're going to store it. So all these are potential things that we really need to consider before we just either move them around or store them without proper storage process. Mm-hmm. So with that, having a good inspection plan is one of the key things, right? We have our own checklist, and along with a repair plan, capture the details. But doing a monthly review, or if you're bringing in your equipment as used basis, like on well testing, for example, every time you bring it in, it'll be good to do your UT thickness checks. I mean, just especially in those areas that erosion tend to happen or corrosion tends to build up. Doing an interior and exterior inspection. Sometimes a simple visual inspection does the trick, right? Mm-hmm. But the interior is a little tougher unless you have a manway and you're able to get in. And then obviously the proper storage. I think this is one of those things that we all tend to oversee, and mainly because, hey, we didn't use the equipment, we're not using it, just put it in the back, right? But because you eventually either will reuse it or sell it or something, you want to make sure you pressure clean it. If you're able to air dry it, that'd be great. And then especially the cover. The threads. We've seen it where even the thread sometimes, because we didn't apply any protection like grease or so forth. We pressure tested the equipment and the plug went out, right?
Now
so
the equipment inspection form, is that something that you have that we can share out to everybody?
Well, absolutely. I think we'll definitely be open to that. And it's a good start. I think we're all going to have our detailed version of it, but at least we'll give them, it covers everything from the pressure vessel to piping to the structural and so forth. So I think it'll be useful.
One of our clients wants it for their lease operators that are going out, and then they just want to give them a quick checklist so that way they can go out there and start kind of running their own integrity system management. So if there's someone, if y'all, whoever's listening wants to have this equipment inspection form, just reach out to us and we'll get that form shipped over to y'all.
Well, that'd be great.
Well, the equipment inspection form kind of goes into the next slide. And on this one, you're really just kind of labeling out the areas that you look out for, or the vocabulary. Is that right?
Well, these are some of the key. I mean, they're not all inclusive, but some of the key things, especially if you're operating, if it's a vertical, it's always going to be on the higher side or the top side of the unit. If it's horizontal, it'll be on the shell side. But we've seen where, especially once you introduce some of the solid gases, those start creating pits along the highest point. The other area we've seen it is where your liquid level sits, right? Especially if you don't really do any maintenance to them, where you maybe drain it once a month and so forth. We tend to see pitting along that liquid level section. We've seen it along nozzle necks, especially if liquid gets trapped in there and it just sits for a long time, it starts heating up that bottom section of it. We've seen it especially on the bottom of the head. I mean, we've had one project one time where, the customer said, hey, I have a little pinhole, we just need to repair it. But a pinhole is only a warning, right? There's something much bigger behind it. And sure enough, I mean, this was a pretty good sized vessel. I think it was a 60 plus diameter, and about 60% of the head was already corroded. A lot of metal loss. It was only basically at a point where it's going to cost an exposure, right? And then on the external side is real similar with a few things. I mean, we've seen where, if you allow a gasket to leak, and you just say, no big deal, it's just leaking a little bit. We've seen it where it started eating the flange face, right? And then so what that's going to cause is either you're going to have to reface the flange or replace it, which is stuff you really don't need to be spending on. On insulated areas, we've seen it where, especially on the lower side, where condensation would occur, and then or rains, it just comes to the bottom. We've seen where all that starts pitting. So, I mean, all those things we have to monitor, because if it goes below your minimum thickness, then you're having to basically either put some welding back in there and increase or put in the metal loss, or you're going to have a weak point, right? And then your vessel's not good for the design pressure anymore. So that's why it's important for integrity management.
So when y'all go in, this next one this is your form, right? So this is what, when y'all get equipment into or when you're doing field work, you document everything that's existing and what's going on, right?
Yeah, if you notice, this form has a pre-inspection once we get it, and a post-inspection before it goes out. And I like it. I mean, it's obviously, I'm being biased, but I think anybody else could take advantage of it. If you have some engineering, just to evaluate what equipment, what do we have about that equipment. It has some quality control, and then it gets into the details of, inspections here, right? It even includes accessories, right? So for anybody like operators that are thinking of using this, it'll be great, because then they could add anything else they want to it.
Yeah, because it even goes into page 2. So now you got piping and skid trailer, because what we're seeing right now is there's a lot of piping. It seems like the piping is what's the interconnection between the vessels. So anything rattling, especially from compressors, we're starting to see a lot of issue with the piping starting to become brittle and breaking down. So this would be a great for lease operators to go out there and do their own little check off list and observations. Like you said, the visual observations, you can kind of see a lot what's going on just on the outside.
Right.
Well, then going into repair saving tips. So I really like these because case studies, everyone likes a case study of what to focus on. So you got 3 case studies here. So we'll kick off on the first one, which is the, okay. So these are 3 case studies. But on your next one, these are the big areas that a lot of your clients have issues with, and the quick repairs, right, before buying something new. So can you explain?
So that's correct. So far we've discussed how to prevent stuff, right? So the first 2 were obviously about, how do we prevent from getting to a repair. But if all that was done, or, now we're at a point where have to do a repair, then we've kind of picked some of the top tips that we've used or we look for when we're having a look at a repair, and how do we save money while still meeting all the code requirements, right? So this is about repair saving tips. On a code versus non-code. A lot of times, especially in the oil field, we have a pressure vessel, but a lot of times we go higher pressures and we say, no, but I want a API flange on. Well, AS&E really doesn't consider or doesn't take into any API materials. So that means that you basically could replace that flange without having to go through the whole repair process with the AI. I still like to get my AI involved in all of this stuff, right? But if it's outside the boundary of what was certified, then technically it's not part of the code, right? So then that means you can do some of these repairs. And that is you could save on replacing something without waiting on somebody. You can get it up and running quicker. So this is definitely a good cost saving tip. So on routine repairs, the MBIC code, the repair code allows you to do certain things, right? So one of them is routine repairs. An example would be, let's say you have metal loss. You could re-weld that area if it's 25% of the thickness or up to about ½ inch without it being a full repair. Now you communicate with your AI and you're able to get their acknowledgement on this and their approval. But what that would do is obviously save you time and money on having to bring the AI or having to wait till he shows up and you're losing time in production, right? So that's where this tip could come in handy, and we've applied it several times, and it's great, especially we have great AI that work well with us, and I'm sure everybody else does too, but I really would consider this one as well as one of those cost-saving tips. Now, this is one of my favorite ones because we all hate to do this, but preheat this post-wall heat treat. Now, especially if the pressure vessel was not impact tested. If it was, then there's other requirements, you can still do it, but let's just keep it simple on if it wasn't impact tested, then you're able to preheat in lieu of post-wall heat treat. So what would that do? Basically, you can do all the repairs, get your AI to review it and all that. But the big savings is you don't have to take it out to the stress relieving oven or like in my case, I don't have one, so I'll have to ship it to the next town, right? Having to wait till it gets back before you do all that process. So if it takes you 2 days to do that, you already saved it here. If you do it in the field, you already saved a tremendous. Imagine having a tower or a contact tower and having to take it all down instead of doing the field repair, preheating, getting the AI to witness the hydro and all that. So you can see how this one can save a tremendous amount of money if you don't have to send it in and get it stress relief. Then the last one is the shop bits field. We like to use a rule of thumb, probably, really anything over 36 inches, you should probably consider doing it in the field. But you do have to weigh in any other considerations, the bulkiness, the size, can you afford to send it in or not? But doing it in the field is going to cost you more money as far as the repair service side. But what you will save is going to be in the removal, the transportation, getting it back, really installing it. All that takes a lot of time and a lot of money, right? So we kind of doing something in the field would justify the cost just by time saving alone. So these are the some of the 4 top tips that you can apply and save in a repair.
That's awesome. Now, I really like these tips because and then you're gonna reiterate with them on your first. You still got 3 case studies. So the first one was the separator nozzle repair. This goes back into what you were talking about actually, we can go over to the first picture. So explain to us what's going on here.
So here's an example. What happened here was, this is from an inlet separator to a compressor. Now the problem here was the connecting piping was in a bind. Basically, it was put in a bind on this nozzle. So through the vibration and the binding, the moment cause here started cracking. And if you click the next one, you'll see that the whole extent of this repair, right? So it really covers a pretty good area. So what we did here was basically we had to gouge it out, do PT, checked everything out, and then re-welded, inspecting internals for penetration, PT the outside, and then of course you go through the process of hydro testing and so forth. But what I liked about this particular project is we recommended a few things. One of the key things was, hey, it's to your best interest to remove the existing spool piece, refabricated or adjusted so that there's no stress on the inlet nozzle. And I think we did this project probably 3 years ago or 4. We hadn't heard back. So evidently what they did and adjusted prevented this thing from having to come back and another repair. So the nice thing about this was planning, like anything, is the key, right? The more you plan up front, the more you save. So this was done in coordination with the compressor company to make sure that it was either on a PM. I think this was done on a PM. So really there was no loss of production.
What was the turnaround on this project?
Well, we received, this one was done in the shop. So let's say we received it one afternoon, and then by the next day, we had already done all the coordination with the AI. So in this case, the AI had to be present. The next day, it was done. The AI was present, hydro tested, and so basically 2 days, 2 full days.
Okay, so just proper planning. Compressor company got with you, said we're having our PM shut down at this time. We're shipping this vessel to you. So it was a quick domino effect. You got everyone in line, so that way it was just quick turnaround. So just having proper preparation for it was key to that.
Correct.
Yeah. So case study. This is your line heater repair. So this is a metal loss due to erosion. So let me go to the picture. Yeah. Explain to us what's going on here.
Well, this is a clear indication of erosion, and this was a combination of more volume and sand. And then every time I see this, it just blows my mind how easy, you could cut through steel, something that's so strong, but when you have erosion, it's very, very easy to go through it. So what happened here is they had a lot more flow and they had sand, and it cut through the 180s basically in the line heater. So one of the things that we looked at is, hey, okay, if you have that one, because they already had a pinhole, it was already leaking. If that one had a leak, then the possibility of the others, especially on the upstream side, that they had also metal loss was high, right? So what we recommended, hey, let us check them all, right? So we did. And so what you start seeing here is that we end up replacing at least 2 of the 180s. And then what that did for the customers, obviously saved them time, because sooner or later, if we would have just done the repair that they requested, it would have come back, because the other one had already probably only 1/4 of an inch to a 1/2 inch left in it, right? So sooner or later that one was going to come back and we're going to have a repair. So in this particular case, the communication we had, the planning, definitely helped in getting this thing fixed the first time instead of having to send it back and then have a repair.
So what I liked about what you just said is, you had a pinhole leak. You're doing your job, so your scope of work is fix that pinhole leak. But because you like partnerships and you like figuring out what's going on, you say, well, if it's happening here, it's going to be happening in all these other areas. you recommended it to the client of saying, at this point, we already have it in the shop, it's already broken down, let's just replace all the areas of high concern, lower your risk of having it come back. And then, of course, with that logic, they said, yes, go ahead and just do all of it. So that's a good partnership. So that's one of the things that I do stress to people is when they're working with their vendors, to have that open communication partnership, because that's what you want. I mean, at the end of the year, when you're doing your taxes with the CPA, you really want them to say, don't do these things. Don't just sign off on it, ship it to the government. So you want that partnership. So no, that's fantastic. Your case study number 3 was the I call Contactor Repair. I did have a picture on there, but this is the picture. So this is from the hat tray looking at it, right?
Yes, this is looking from the top, looking down at the hat tray, right?
Okay.
Unlike any of the other repairs here, they all had to do with process, right? Whether it was overdoing something or the flow. This in particular was actually, manufacturing related. It was, the well was just, did not penetrate to the walls properly. So therefore, once liquid got behind the well, it was just a matter of time before it was going to leak. So what you're looking at is just a fillet well, right? So there was no full penetration. So once it got right behind it, it went right through the hat tray. So this particular one here, what we had to do, and again, communication, planning is very essential. Customer said, hey, can we take the whole hat tray out? Because we want to also inspect other things in there, the mist pad and so forth, because now we're not 100% sure, right? So what we did is we took it out, inspected all the other areas, they were fine. And when we put the hat tray back, we did a full penetration weld. So if they would have done that at the beginning, they probably would have avoided this, to be honest with you, because it would have been real tough. Well, unless of course the welding wasn't done properly, but
right.
But we did a full penetration weld and added a little bit of extra to make sure that this hat tray would not have any issues in the future. Now this was a little complex too, because it was an existing contact tower, so we needed to make sure once we cut it and aligned it back together. I mean, you're talking about try to be within an 1/8 of tolerance to make sure that when they put it back in service, they weren't going to have any issues installing the rest of the piping and connections. So here we go. You're talking about cost savings. We talked about what we did. We inspected other components. That saved them money from having to bring it back in the future. And then one of the key things here is all the savings really occur in the planning and the turnaround. I think this one was out within a week. Only because this one did have to go through the whole process of x-rays and inspecting other internal areas.
That's good. Well, those are the case studies for that. Your next section was the repurpose, alterations, and re-rates. And right now, I'm glad you did this, because apparently every time I talk to you, I'm getting re-rates and repurpose backwards. So I'm glad you put the vocabulary here for us. Yeah, go ahead and explain to us what do you mean by alterations and re-rates?
Well, so far, of course, we did the prevention, we did the repairs. Now we're saying, hey, I got this piece of equipment. Can I do anything else with it? I mean, instead of just saying, hey, this is a two-phase separator, that's all it's good for. No, we like to think outside the box. How can we reuse this or modify it, etc. So when we talk about an alteration, it's basically modifying an existing equipment to improve either efficiency, customer requirement, adding additional process ports, etc. When we talk about re-rates, it's basically changing an existing equipment condition, whether it's lowering the pressure. Sometimes it depends on how it was designed. You might be able to increase it a little bit. Sometimes it's maximizing the temperature. Ideally, you like to design equipment to be maximized, but it's not always the case. So you could always look into it and see if you could do some re-rates. And that way you could take advantage of what you have. Now, the repurpose works in combination probably with the alteration. And that's basically converting anything you do have. Let's say you have a contact tower that is not really functioning anymore, and you don't want to go through replacing the trays, but you can convert it into a pack tower. That'd be one way to repurpose it. If you have a two-phase separator and you say, I need a three-phase, well, that'd be, you could convert it into a three-phase. That'd be another way to repurpose that. Sometimes just saying, hey, you know what, I don't operate at 1440 anymore, so even though I've lost metal on my pressure vessel, can I derate it to a lower pressure and still not have to replace it? And you can. So that's the repurpose side, just thinking outside. How can I use it for something else that wasn't intended for, right? So those are the three things to consider in this step.
Well, that's good. And everyone's trying to save money with what they have. So if you can just do an alteration, re-rate, repurpose, and use what you have and only spend 20 to 30%, 40% rather than buying new, I think everyone's going to be pushing on that. You have 3 case studies also explaining some examples of what you're talking about here, which is great because it's good affirmation. So jumping into the first case study, let me go in. Repurpose and alteration. So it's a combination of 2 out of the 3, but it's a sand separator, traditional, and then you made it into cyclonic conversion. Mostly it's because improving separation efficiency. So did this come from the client, or did you work with a client of saying, do you have something that we can just convert it for you?
Well, what happened in this particular one is, the cyclonic version came into a pretty big demand over the past couple of years, right? So, up until about probably 4 or 5 years, everything was what we call traditional sand traps. So then the cyclonic does give you a better separation. I think it goes even up to about 98%. A lot of it has to do with the operating side. But this was one of those that the customer said, hey, is there any way I got these sand traps? I mean, I don't use them. I can't use them because they don't want traditional. Do we have any options? So this is one of those that we say, hey, we'll have to remove the head so we can see what you have internally, and then we could repurpose it, gut it out, because they had a couple of diverters and things like that inside. We gutted it out and then applied our cyclonic, inlet device to make it cyclonic, modified the nozzle, added a new nozzle, because the cyclonic are real tough because you have to get to the end to really make it a true cyclonic. There's other ways to design it, but you see here, basically it's at the very end. So it requires a lot more metal and so forth. Even the cutting is a lot tougher. But what this did is obviously we repurposed a piece of equipment that the customer had, and their customer was basically requesting a cyclonic, right? So here we'll go into some of the benefits that we did here. Once we gutted everything out, this is the end of it, but basically you have a new vessel or a new sand trap in this case. So the benefit here was obviously 2 big things. One was cost. We probably saved them, or they saved, right? I mean, in conjunction, about 60% of the cost. And then at that time, I mean, it was taking 6 weeks just to get materials in to build a new one. So at least they saved 6 weeks of time to where they could actually start producing money instead of waiting for something. They actually took something they had and we converted it into something that was producing revenue in a lot shorter time.
Yeah, absolutely. Yeah, and your case study number 2. So again, it's 2 out of the 3. You have repurpose and alteration, test separator extension. I really like this one because I actually have a client currently that is looking for something like this. So you added liquid capacity and settling time. So this is their existing equipment, is that right?
That's correct.
Yeah, so this is what they had.
Basically they had some production separators. I think these were really more test separators. They didn't have the mispad and what have you inside. or test separators, and they were trying to evaluate what can I do with these. And they were looking at ordering a larger separator to meet the customer requirements, and then going through the process and understanding that they had these available. We recommended the alternative of extending these in lieu of going to a larger vessel.
Yeah, actually. And that's what you did here. Is that like added another 5 feet or so to that?
That's exactly right. So basically, instead of 36 by 10, we converted it into a 36 by 15.
That's awesome.
So this one's even greater. I mean, you know, we probably saved 75% of a new one in this case. And then the time, it was at least 6 weeks of saving. So basically, by the time they brought it in, we were already preparing that separator. By the time we got the shell in, we were ready to put it together. All the modifications that we did, some improvement internally to it as well. So overall, this is what, you know, if we run now, especially in today's time where we're trying to save money on anything we have to do, these are things that you really would want to look at as repurposing some of your equipment.
Absolutely. And your case study number 3 was mostly focusing on alteration in inlet separator vane pack, added gas capacity, and separation efficiency. So let me go to the picture right quick. So explain to us what's going on.
Sure. I like the first two. The first two were done in the shop. This particular one was actually done in the field. What you're seeing here is more of a shop picture. But basically, this was a standard design. They had a mist pad based on their flowing conditions, their gas requirements. And then down the road, what happened is they started increasing the required capacity. So instead of trying to modify and do a new vessel and all that kind of stuff, what we did is we added a vane pack to allow them to have that required separation of mist. And therefore, this was done in the field. So one of the key things to do anything in the field, especially when you're driving from South Texas to, let's say, you know, Midland or any other places, preparation, right? So we already had everything cut out. All the materials were here. It was prefab. So by the time we did go to the field to do the job, it took us probably longer to get there and come back than it did to do the job. I think in one day we already had installed it, and it was up and running basically.
That's awesome. So the field repair, you saved 80% on this one because of reduced transportation. Oh, because you did it in the field.
So this is one of those. It was a larger unit, 72 inch by 20, and then it was already piped up with all the it was skid mounted basically. So this was easily around 80% by the time you consider having to load it and transporting it, and it was a wide load. So all those things come in effect. So it's just, I mean, really considering doing something in the field plays a big role. Of course, there's other factors, whether you want to look at safety hazards, you outweigh your risk basically. But this one, even the turnaround, by the time they would have loaded and brought it over, we would have lost at least 2 weeks. So, I mean, this is one of those key things that you could easily implement in the field and be up and running at a lot quicker, and therefore your production is not shut down.
Yeah, so I know this is one of the last slides, but so from this presentation, I mean, what I'm getting is everyone's tracking what they have. They're trying to live with what they have rather than no one's really wanting to invest money right now, just with the market it is. You know, usually in an election year, everyone's already kind of cautious. But when you got oil and gas prices being hampered by COVID, you got election going on, you got protests going on, everyone's just kind of, let's just kind of stay at par. And then what I like about what you're doing here is everyone has to maintain their assets, but now they're moving it from one location to another. Parameters change, oil and gas wells, life changes, decrease in volume, H2S might increase, whatever it may be. But you're saying not only just have it out there, but you can make alterations to the existing equipment to make things work. So that's when we have clients coming out to Croft, we're going to kind of put that in our head because we do a lot of simulations of, flow simulations, composition of gas. This is what you're needing. But that might be one follow-up question that we'll have with our clients now is, what existing equipment do you have that can match this? Or, like you said, bubble cap to structured to packed, changing out certain things, going from that existing mist pad to a vane. I mean, you can meet the specs that you need just by altering existing equipment. So do you right now, do you get a lot of phone calls at people asking those type of things?
Well, that seems to be the general consensus right now is used equipment and repurpose and either used equipment in this case, for those customers we do know it's more along what we're proposing is anything you have right now, I'll put it to use, right? So whether it's repurposing to something else or just reconditioning to where you still can use that piece of equipment in the future.
All right, well, we got a Q&A section at the end, but I want to go through some quick messages right now. So we do have some upcoming webinars. We're talking about flow services on LAC units and meter runs, Chris Crow with burner management and maintenance, and then my own director of engineering, Chris Smithson, who's going to be talking about JTs and fuel gas composition. If you're on the webinar today, we have your information, but please reach out to us if you want a PDH credit shipped over to you. Reach out to Tori, or you can reach out to me on LinkedIn saying, yes, I want one. If you're interested in being a webinar speaker or know of someone who would be a good fit, please reach out to us. That way we can get this information, start sharing this information more. The email below, tori.balagura@croftsystems.net, should be the main contact. Get your information, and then I'll start working with them to get them on board. It wasn't that bad, Jesse, right? You're not that nervous coming on?
Oh, well, I will say this is, I really don't do this often. So, but I think it's really, we need to give back, especially if we already learned all this stuff. I mean, I'm very grateful with others. I mean, it really, I've learned more from others, and I hope I continue to learn more from others than myself, because that means I didn't have to pay for it, right?
Well, and that's what, so if you're on the presentation today, the webinar today, please give us the feedback. Again, I'm Black Belt Six Sigma. I love data. I love continuous improvement. So let us know how it would be better fit to tailor your needs and what you're looking for. So this is a part of the Q&A section. So again, if you're on it, if you got specific questions about maybe you have existing equipment that you're trying to alter, this is a great time to tap into Jesse's knowledge. We do have 2 loaded questions I have for you, Jesse. But then again on that is, if you are looking for the equipment inspection form, do let us know about that, so that way we can ship that over to you. This is a form that O-Synergy uses to monitor what they're doing and the integrity of their systems. So right now I got one question for you, Jesse, that came preloaded. So a person has a 2-phase separator, but they honestly need a 3-phase separator. Is it even worth it to convert it to a 3-phase, or would it be, it's easier to go from 3-phase to 2-phase. That's just a level controller, but going from a 2-phase to 3-phase, is it worth it to convert it or buy new or use one?
Well, the first thing I would ask is what size is it, right? But for the most part, the general answer would be yes, it's worth it. For the most part, I mean, you do have to remove the head, and then you have to put your spillover plate and then add your additional nozzles to be able to convert into a 3-phase. But one of the first things you want to know, what size is it? I mean, it's, if it's a very small one, then maybe, it's borderline, but anything above 30 inch, absolutely, even 24 inch, absolutely. Plus, it's going to save you time, right? Unless somebody's trying to get rid of equipment, and it's pretty cheap, then you might want to evaluate that.
Well, no, that's absolutely true, and they didn't go into specifics on it. The other question that they had was they moved a contact tower to a new location, and it looks like the bubble caps that are in there that they increase the velocity through them. So because they're not making good bubbling through the inspection ports, how hard would it be to go in there and redo the bubble caps on that existing contact tower?
Well, again, it would depend on the size, but basically, you know, if it was a pretty large, you know, contact tower, you'll have a manway and you're able to go through there and remove them. But if it's a smaller one, you would have to cut the head and start pulling the trays and putting new trays in there. So, you know, everything's doable. And in this case, it's almost worth it because you're going to be saving on having to buy a new tower.
Awesome. Well, we don't have any further questions right now, but that doesn't mean that questions aren't going to come in. We have our LinkedIn contacts below. If you have any questions that come after us, you start driving, that's when the big questions always hit me. Do reach out to Jesse. He is a great resource to have if you want Croft to handle with our engineering firm. Mostly we're going to be partnering up with Jesse on the future projects anyways, but reach out to both of us. We're here for you. But Jesse, I definitely appreciate you coming and talking with us today.
Thank you for having me.
All right, so we're going to end the webinar here so everyone can get to lunch. All right, thank you again, Jesse.
Thanks.